I hope you guys are doing well today. So today we're moving from systems of equations to something totally and completely unrelated, which is Pythagorean theorem. Now, what Pythagorean theorem is basically saying is when we have a right triangle, we have the hypotenuse, which is right across from your right angle. Oh my goodness, I don't know why that did that. Sorry guys. All right, so you have your hypotenuse, which is right across from your right angle, and it's also called C. So this is the hypotenuse, and it's right across from your right angle. It's very important that you remember this guy right here as the hypotenuse, okay? Pretty much what you're going to be looking for today is this hypotenuse right here. Now, you also have A and B, which are connected to your right angle, and both of those are called legs. So they are connected to your right angle and called A and B. Now, it doesn't matter which one is A and which one is B, because both of them are going to be A squared plus B squared equals C squared. So the only thing that really matters is that your hypotenuse is C. So you have your two legs, which are connected to the right angle, and you have your hypotenuse, which is across from the right angle. I usually will draw a little arrow across from that right angle to show where my hypotenuse is, and I know that my legs are attached onto that right angle. Okay, so basically, we know that A squared plus B squared equals C squared, and that kind of looks like a plus sign, so I'm going to redo it as an equal sign. This basically over here is a proof of Pythagorean theorem, but we're not going to deep dive too much into that today just because it's a lot for you guys to learn without me being there. So we're just going to focus on the math today. And I want you all to take a deep breath because this is going to be so much easier than systems of equations. Like a few of the students have done this in Flex already, and I think they would agree that it's a lot easier. All right, so go to example 1. By the way, if you don't have this packet in front of you, go pick it up from the wooden table. You know where it is. Hit the pause button, go pick it up at the wooden table. Okay, so now that we know what Pythagorean theorem is, let's practice it to use it to find the length of a hypotenuse of a right triangle. Now, here is something very important that I want you to note, and I want you to write this down. Pythagorean theorem only works with right triangles. So that means if you don't have a 90-degree angle in your triangle, then Pythagorean theorem won't work for it. So all of these triangles are going to have a right angle in it. Okay, so we have 6 and 8. And just as a reminder of what these are, we can see that these are attached onto our right angle here, and therefore they're called legs. And our hypotenuse is right across from our right angle, and we're going to label that hypotenuse. And just as another reminder, we label our legs as A and B. Now, we remember that Pythagorean theorem is A squared plus B squared equals C squared, okay? That is the formula for Pythagorean theorem. And as long as you know this formula, you should be good for this entire unit. Now, will it get a little bit more complex? Absolutely, but this formula right here is the basis of everything. So you have A squared plus B squared equals C squared. So we have a 6 right here that we're going to plug right in for A. So we're placing that A with 6. And don't forget to put your little squared up there. Now, we have B, which is 8. So we're going to write down an 8 and put a little square right there. And I'm going to wait for you guys to catch up to where I am. If you need to, you can pause the video at any time. Now, we haven't figured out what this hypotenuse is, and so we're going to write it as C squared. Now, something that is really, really important for you to know is that these little squares up here, they absolutely do not mean multiplication by 2. What a square is when you're multiplying a number times a number. So what this would look like for this 6 right here is 6 times 6. And 8 times 8 equals C squared, okay? So that's what the square means. All right, so 6 times 6 is 36. And 8 times 8 is 64, and that's equal to c squared. Okay, so then we're going to add together 36 and 64, and that equals 100 equals c squared. Now, you might think to yourself, oh, look, we solved the left side of the equation. We're all done. Not quite. So we still have this c squared right here, but we're not looking for c squared. We're looking for c over here. We're looking for this c right here. So how do you get rid of this c squared right here? Well, there's this thing called a square root. And the square root is essentially the exact opposite of what? The square root is the exact opposite of what a square is. So basically, the square root of 36 is 6, and the square root of 64 is 8. So we have to find the square root of 100. So in our little square root symbol, I know that 10 times 10 equals 100. And that's going to be equal to c squared. We have that little right there. So since I know that 10 times 10 equals 100, that means the square root of 100 is 10. So c equals 10. And that's the length of our hypotenuse. Now, did I make that way more drawn out than it needs to be? Absolutely. So in the next couple of examples, we're going to kind of shorten it down, and hopefully that'll clarify some things. Another thing to note is that when it doesn't work out perfectly like this, because you're going to be working with decimals a lot with this, because square roots are typically not perfect. You have on your little calculator, on your yellow calculator, so I want you to look at your yellow calculator, pick that thing up. Above the 7 is a little blue button that has a square root symbol. And you're going to push that square root symbol and type whatever a squared plus b squared is into that, and it'll give you what c is, okay? All right, so now they kind of walked us through it right here in this little example space right here, just like I did. So they said a squared is 6 squared and b squared is 8 squared, and that's going to be equal to c squared. And then they said 36 plus 64 equals c squared, because, 6 squared is 36 and 8 squared is 64. And then they said 36 plus 64 is 100, and that's equal to c squared. And then they said, since we know that 100 is 10 squared, we can say that the hypotenuse hypotenuse c is 10. So they basically just walked us through that whole problem just like I did with you. All right, now example 2 says determine the length of the hypotenuse of the right triangle. So the first thing we're going to do is we're going to label our parts of the triangle. So I'm going to draw an arrow over to where the C is, and I'm going to label this with a hypotenuse, because the hypotenuse is always across from our right angle. Then we have our legs, which are attached on to our right angles. So we have leg A and leg B, all right? So leg A is going to be 3, and then we're going to make sure that we square that. And then we have leg B, which is 7, and we're going to make sure that we square that. And then we just don't know what c squared is yet, so we're going to write in c squared. And we're doing this based off of, remember, Pythagorean theorem, which says a squared plus b squared equals c squared. Okay, so 3 times 3 is 9. So 3 squared is 9. And 7 squared is 49. And c squared, we don't know it yet. So 9 plus 49 is actually 58 equals c squared. And you might know this from your perfect squares, but that's actually not a perfect square. So when we take the square root of both sides, because remember that's how you get c by itself, you're going to have to use that little button that's right above the 7. So you're going to say the square root of 58. Now, I want you to type into the little box off to the side once it pops up what the square root of 58 is, rounded to the nearest tens place. All right, go ahead and type that in. All right, so if you said that c equals 7.6, you would be correct. All right, now we have our exercises, and we're just going to keep going through these together, and I'll let you do the last few on your own, but we're going to keep going through these together. So we have this right triangle right here. Now, this is the first time we haven't seen the right angle at the bottom left. In fact, this time it's at the top left, but we still know that the hypotenuse is right across from that right angle. And we still know that the legs are attached on to that right angle right there. Okay, so then we're going to call this leg A, and we're going to call this right here leg B, and we're looking for c squared, remember? All right, so we have a squared plus b squared equals c squared. Now, leg A is 3, so for A, we're going to plug in a 3, and don't forget to write your little squared next to it. Now, leg B is 4, so we're going to write down 4 squared. Don't forget to put your little square there. And then we don't know what c is yet, so we're just going to write down c squared. Okay, so 3 times 3 is 9, and 4 times 4 is 16 equals c squared. And then 9 plus 16 is 25 equals c squared. Now this one is a perfect square, so I want you without your calculator to see what c would be equal to. Okay, and if you got that c equaled 5, you would absolutely be correct because 5 times 5 is 25. So the length of the hypotenuse is 5. And what this is called is it's called a perfect Pythagorean theorem example. Ooh, I spelled that wrong. Pythagorean example. And that's because all of your numbers end up being whole numbers. This one up here, you had a decimal there, so it wasn't really perfect, but this one down here is perfect. And we'll talk a little bit more about this later, but for now, I just want you to master that a squared plus b squared equals c squared and entering things in. All right, so now let's move on down to number 2. All right, so we have this right triangle right here. So I want you on your own to try to label those parts of the diagram with leg, hypotenuse, and leg for the other one. And it doesn't matter which leg you label as A or B, just as long as you label it. All right, go ahead and get that done. All right, so remember, your hypotenuse is right across from this right angle over here, so we're going to label this with the hypotenuse. And what's attached onto this right angle right here is a leg, and this is a leg. And I'm going to call this one leg A and this one leg B. So we have a squared plus b squared equals c squared. So leg A, is 8. So we're going to plug in an 8 right there, and don't forget your squared. And B is 11. So we're going to plug in a little squared right there. In 11, and we still don't know what c squared is, so we're just going to leave that one alone. All right, so we know that 8 squared, 8 times 8 is 64, and 11 times 11 is 121, and we still don't know what c squared is. So then we're going to have 64 plus 121, which is going to add up to equal 185 equals c squared. So now you're going to take the square root of both sides and enter that into your calculator to see what you get. If you got 13.6, you would be correct. So the length of our hypotenuse is 13.6. Now I want you guys to notice something. Every single time our hypotenuse has been bigger than both of our legs, and that's never going to change. Your hypotenuse is always going to be the longest side. So I want you to make a little note of that at the top. The hypotenuse is always the longest side. All right, let's move on to example number 3. All right, so go ahead and label the parts of your triangle. All right, so this right over here is across from our right angle, so we're going to call it the hypotenuse. And then your legs are attached right on to that right angle. All right, and we're going to call this leg A. Actually, we're going to call this one leg A. And we're going to call this one leg B. So we know that leg A, actually, we know that Pythagorean theorem is a squared plus b squared equals c squared. Drill that into your head. It's not going away. So we know that leg A is 4, and we have to attach that little square onto it. We know that leg B is 9, and we have to attach that little square onto it. And we still don't know what c squared is. So 4 squared is 16, and 9 squared is 81 equals c squared. So now You'll add those two together and you'll get 97 equals c squared. So now you have to take the square root of both sides to get it by itself. You have the square root of 97 is 9.84. All right, I'm going to leave you to do number 5 on your own. So this is going to be the last example that we do together. And then I'll walk you through number 5 after you try it on your own, okay? All right, so we have across from our right angle is our hypotenuse. So our hypotenuse is here. And remember, our hypotenuse is our longest side, so you can also look for that. But with this one, it's a little bit difficult to see. And we know that our ones attached on to our right angle is our leg, so we're going to call this leg and leg. And I'm going to call this one leg A and this one leg B. And we know that Pythagorean theorem is a squared plus b squared equals c squared. So leg A, we're going to put a 2, and don't forget to square it. In leg B, we're going to put a 5, and don't forget to square it. And we don't know what C is yet. So 2 times 2 is 4, and 5 times 5 is 25. We have C squared. 4 plus 5 is 29 equals C squared. And now we just have to take the square root of both sides. And once again, this isn't a perfect square, so we'll have to use our calculator. And we know that the square root of 29 is 5.4. All right, now I want you to go ahead and try example 5 on your own. The first step should be to label the legs and hypotenuse. So you don't have to write this down, but I do want to go through those steps with you. Label the legs and hypotenuse. Label A and B. And then after that, write down a squared plus b squared equals c squared. 4, plug in A and B into their appropriate spots. And then you're gonna and then you're actually gonna square them. Which remember is just multiplying them by themselves. And then for step number 6, you're going to add a squared plus b squared together. And then you're going to take the square root of a squared plus b squared, and that's going to equal c. Okay, so go ahead and do that one on your own, and then we'll come back together and do it together. All right, so across from my right angle is my hypotenuse. And then attached onto my right angle is my legs. So I'm going to label this leg A and this one leg B. Leg A is 1, so I have 1 squared. And leg B is 9, so I have 9 squared. And that's going to add together to equal c squared. 1 squared is just 1. And 9 squared is 81 equals c squared. So that gives us 82 equals c squared. Now our final step is to take the square root of both sides. Now this isn't a perfect square, so we're going to have to round. And if you got 9.1, you would be correct. So the length of our hypotenuse is 9.1. All right. You guys should now be ready to go ahead and complete your exit ticket. So if you'll go to OnCourse and get that exit ticket done, it is a 15-point grade. And if you don't do it, you will get a 0, which will probably drop you down a letter grade. And I will also give you an infraction if you don't do it. So make sure you get that done. You should have plenty of time to do it. Go ahead and get it done. Now, after this lesson, you should also understand how to do the first 5 for today. So go ahead and get your first 5 done as well. But make sure you really get that exit ticket done because I don't want to be handing out infractions when I come back on Monday. All right. So after you get that OnCourse ticket done, after that, you're going to go do the quizzes in Google Classroom and then a math journal. And then right after that, you can do some Delta math that has to do with Pythagorean theorem. I hope that this lesson was easy for you. And if not, feel free to send me any emails or questions that you have. But we'll be working with Pythagorean theorem all week. So if it didn't make sense to you today, hopefully it'll make sense to you next week. All right. I hope you guys have a wonderful weekend. And I'm so sorry for not being able to be there with you today.